Okay. All right. So for some of you, I already done a little bit here and there. MCQ, anything? No, yeah, I know you don't need. I'm asking them. Yeah, asking them. MCQ. Not yet 是什么意思? Okay. So far, I don't think so. Okay. Yuheng, anything from MCQ?
No, nothing MCQ.
Nothing from MCQ. Oh, MCQ all can do. Okay, can. Right. Anything here? Hey, yeah, why you never go and write the translational equilibrium? You know this, right? Not that you don't know, right? How come you didn't write? You didn't know you had to write. Why? Because you think this one is moments only. Yeah. Hey. So if the question is just generic, like the equilibrium, right? Write both. Translational and rotational equilibrium. Okay? Alright, I'll leave that to you because I'm very sure you can pick this off the definitions from your school's notes. Anything else?
For rotation.
Oh wait, hold on. Yuheng, yes.
I got marked wrong because I wrote algebraic sum of its clockwise and counterclockwise moments. Am I supposed to write its clockwise moments and counterclockwise moments? Is that why it's wrong?
Okay. Firstly, why did you go with algebraic sum?
I thought that's the definition.
Is it? Algebraic
like
sum?
In the notes.
From your school's notes?
Yeah.
Oh, I wouldn't know. As in that's not normal actually. It's not something that I hear very often.
But anyway, they put a caret mark next to the clockwise. So is it because I need to write clockwise moments and counterclockwise moments?
Yeah, sorry. Let me look at your paper. Sorry, I'm a bit confused because I would have to open your paper.
Okay.
Yeah, don't worry. I mean, I just want to make sure then. I just put it to the side. Don't worry. Oh, that's so weird. That doesn't make any sense. The algebraic sum of its clockwise and counterclockwise moments about any axis is 0, right? I don't know, man. It sounds like the teacher just kind of like just didn't give you the mark because he himself didn't read it carefully.
Oh.
Yeah. I mean, I don't see anything wrong with your answer. Do you think that could be the case?
I don't know. I thought it's because I had to write clockwise moments and counterclockwise moments.
Yeah, but I mean the language is okay, what, right? It's like language is not a big thing. It's a bit ridiculous for them to mark you down based on the fact that you didn't write the word moments, but you did write clockwise and counterclockwise moments. It just sounds like the teachers may be overreacting for this, man. I'm sorry.
Oh, so I should appeal it.
Yeah, you should have been given a 1 mark there, I feel. Yeah. I don't know whether is it just a matter of like, oh, I didn't see the word moments. Like, maybe he just breezed through the word moments or something like that.
Okay.
That's annoying. I'm sorry, man. Yeah.
Yeah.
Anything here? Yep. Oh. Did you show the cancel? You wrote G and you showed the cancel? Is that what you're saying? Oh, you didn't write G at all. So you're saying that you mentally cancel G. Yeah, then that's wrong. Yeah, you don't do that. You never ever mentally cancel G. Oh, that means then that means you got marked wrong for something else. Yeah, probably sure of that. I believe if you didn't write G, they will still give you the BOD. Yeah, they'll give you the BOD, but if your teacher wanted you to learn a lesson, they'll take away 1 mark from you. But the problem is that you missed out the calculations at the bottom also. So that one's all gone already, man. Yeah. What's the concern? So like I say again, okay, do you all understand that A levels, right? There is no true mark scheme. Do you understand when I say something like that? There's no actual mark scheme that's provided, that's available online for you. Do you understand that? Do you know the TYS, the mark schemes? Yeah, 10-year series. Oh wait, he doesn't understand TYS because have you even touched the O-level TYS before? No wonder. Okay, so TYS is 10-year series. So the A-level 10 series, the mark scheme is by the publishers. EPH, Xingli, they all write their own mark schemes. Yeah, there's no standardized mark schemes available out there in the market. And no, it's not about Cambridge. It's SEAB. Singapore Examinations and Assessment Board refuses to give out any real answers. Yeah. Do you know what's the backstory to it? The backstory is that they actually don't have a mark scheme, they have a guideline. Then they will take sample answers from students. Then they'll compile these sample answers. This will be a grade 3 answer. This will be a grade 2 answer. This will be a grade 1 answer. So if your answers are similar to the grade 2 or grade 1, then you don't get the full mark. That's how they do it, apparently. Right? I don't know. So that's why you will see, right, all the TYS answers, you will see them over-explaining a lot of points. Because some of these TYS answer key, right, the publishers hire ex-SEAB markers. And they hire them to write these answers, right? So, but then, SEAB markers, they are not allowed to divulge any secrets. They sign an NDA for life. They are not supposed to say anything. Right? If it comes out that they did say something, that's it for them. They will go to jail. Yeah, it's no joke one. It's all confidential, top secret even. Yeah. So which means that, but then there's a certain style to it. So you will see that they have written it to a certain, this one also forget to write G. And that's why your teacher decided to punish you for it. Right? Is that right? Or something else? Oh, is that it? Yeah, okay, yeah. So it really depends on whether or not they decide to give you the benefit of the doubt. But moments is moments, right? Moments is force times distance. You cannot take mass times distance. Right? So factually, technically, right, they have every right to take away the 1 mark. Okay? So if you ask me, should I write G? Yeah. In fact, right, from now until the next year, right, what I get from most A-level students, right, that whenever you do the questions is, do I need to write this? Do I need to write that? And my answer 9 times out of 10 is always, yes, you have to. Right? Because there's this tendency to try to answer it in the shortest way possible, in the simplest way possible to make it to make it feel like, you don't have to put in that much effort to get the marks. Right? But, it is what it is. The A-levels is a wayang show. You understand what that means? Wayang show. Don't know? Right? When you go to army, you will realize what a wayang show is. Right? It means you've got to put on a show. You got to be formal about it. Right? You know letter writing, to whom it may concern. Then the date, then the address, then the person they're referring to, or whatever it is, right? Dear John. Right? Then you're supposed to write it on this side or that side, right? Letter writing, right? Why do we have to go through all that? Because there's a formality to it. It's the same thing here. There's a formality to it. That's what A-levels is quite about. I know your brains are like, it cancels out what? Why do I need to bother? But there's a formality to it. Okay? Because while you don't show, someone else is showing. Right? And what do they look out for? You got to think about this. What's the objective of this A-level or this stupid education thing? What's the biggest objective to it? Yeah. It's about how you can translate or transfer this knowledge to the next generation. If you transfer knowledge like this to the next generation will be messed up. Sorry. Right? They will make mistakes. So they grade you about your ability to transfer this knowledge to the next generation. Science is science, right? How good are you at transferring knowledge, science knowledge to the next generation? If you show this, someone picks this up. Let's say all the material on Earth are destroyed one day, right? And this is the only surviving copy of any science material left on Earth, okay? And someone picks it up. Oh, the mass times the distance gives you moments. Gone. Okay, gone. Right? You get it all wrong already. That's the key. You got to have that mindset all the time whenever you're doing questions like this. Okay, What else do you need from me here? Come. I got about half an hour. Question 3. All right, let's do question 3. 3. Oh, no, FC is centripetal force. Oh. FC is not a real force. Sorry, can I understand what you're talking about? Yeah. What did she say? You can't write FC? I don't understand. So you're not allowed to write N minus mg equals FC? Oh, you're not allowed to write that? Hang on. So you N B minus mg equals FC, is it? Oh, I see. That's ridiculous. I'm sorry. That makes no sense. Yeah, I'm sorry, man. That's ridiculous. Yeah, it's ridiculous. It's one of those pride things. Like the teachers are proud, right? Because the teachers say, I said it to you already, what? Right? That sort of thing, right? So you're not supposed to write FC. So unfortunately, it's an in-house thing. Just like end correction. You know? And one more thing, all right? So RI is very popular for this, completely inelastic collisions. Right? Do you know what the rest of the other JCs, all other JCs, do you know what they use? Perfectly inelastic collisions. Like if you write perfectly inelastic collisions, you'll be marked wrong in RI. Yes. Huh? Wait, do you learn it as perfectly inelastic or completely inelastic? You learned it as completely right. Are you aware that another possible term is called perfectly inelastic? You're not aware, right? That's because you all haven't experienced like outside school stuff, right? All the other schools call it perfectly inelastic. Perfectly inelastic collision. Right? The moment you write this in RI, you get marked wrong. Okay? You know why? Because in the school's notes, your school's note says that it's completely inelastic. You're not allowed to write perfectly. You're not allowed to write anything else that's from the school's notes. That's super annoying. That means what? All the others get it wrong in the A levels. You're not taking the same A levels, is it? Right? Your RI says a special A levels, RI A levels, is it? No, right? So yeah, please, right? Understand that you know this some things are in-house problems, right? And it's very hard to catch that. But since you all are here, you all have a community going on, right? You know, you all can help each other double check. Because to me, this is perfectly fine. This is perfectly fine. Maybe if you want to play it safe next time, I would suggest you do this. You can write equals to Fnet equals to FC. Yeah. Yeah. Oh yeah. You have to distinguish which n are you talking about because it's not the same n. Yeah, the n is changing. Vertical circular motion n changes. Yeah, vertical circular motion n changes. Oh, touch up on this. Do you know why perfectly inelastic according to RI is wrong? What's an inelastic collision? It's a collision where what? Be very specific. Kinetic energy is lost, right? Ke is not conserved, right? How can that be perfect? That's nothing perfect about it. That's what the words are when they said it, right? That was many years ago. Many years ago when the PhD guy was writing the notes, right? He said it to the class. There's nothing perfect about losing Ke. So why are you calling it perfectly inelastic? But the rest of all the other JCs are doing perfectly inelastic. Yeah. I don't know whether he's still there, lah. He's this weird old guy, but he has a PhD. He likes to say that all the time. Yeah. I have a PhD. I have a PhD in physics, you know. If you hear someone like that in school going around like that, you know that he's the guy who wrote the notes. Right? So in RI, you've changed it to completely inelastic collisions. Anyway. Okay. So the small nitty-gritties like this, right? Unfortunate, right? Sometimes the teachers are just very nitpicky about it. So that's something that we can't prevent. Right, what's the next one come? That's a both thing lah. You get kena minus marks for all these kind of things. It's not like you don't understand the concept. You understand the concept, what? Me cannot write this. FG provide for FC. Wait, what do you have to write out? What? Nonsense lah! Ayo, my gosh, how old is this person? Who's the one marking this thing? Who? How old is this person? What, like this 2025 ready, man? Like give cannot lah. Provides yes, but give cannot. Provide is okay. But yo, like that out of nowhere lose 1 mark for nothing, Cassandra. That poor thing also no, don't know why the teacher like that. Goodness. They're not nitpicking on they're not giving you tough questions, but they're nitpicking on the small things. Oh yo. You have to write out in words, gravitation. Ain't nobody got time for that. Which one? Come. 5. Why? This one here. So they give you H, right? They give you H. Okay, but the x-axis is not displacement, right? Okay. But do you understand that the basic graph, it looks like this? Yeah, you understand this, right? Okay. But this graph is what? Energy versus what? No, energy versus displacement. And so in the middle is what? Displacement is equilibrium, right? Displacement is 0, right? So to this side is what kind of amplitude? Negative amplitude. To that side is positive, right? So the problem with this question is they ask you for H. H is not displacement. H is just height below the surface. Down here like this. So you kind of like have to have an offset. Like what's the smallest value of H? Like how high does this block of wood go up to? 2 cm, is it? So you're saying that the block can go up like this, right? Let me just draw it for you here. So I try to draw the same size block. So the block can displace upwards like this, and the height below the surface is just 2 cm. That's what the maximum negative amplitude, right? Right. And then later on it can go further down. Is it? Okay. Right, all the way to a distance of 6 cm, is it? Okay. So what would it mean is that your graph has to fluctuate between 2 and 6. Right? Which graph are you talking about? Sorry, are you talking about the energy graph? Because I thought you're talking about this one. Are you talking about this graph? Oh, okay. Right, because you're not looking at that graph. Are you looking at the one before? Yeah? I mean, which part of it are you not sure of? Yes, that's right. Yeah, 4 is equilibrium. And the deepest that it can go into the water is, right, which is basically what I'm drawing here, right? The deepest in which the bottom part of the box, because H is measured from the surface to the bottom part of the box, right? So the deepest it can go, which is I think maybe that's the reason why it's damn confusing, because when the box goes down, the graph goes up. You know, you're taking downwards as positive. Yeah, right. So the deeper the box goes in, the greater the graph goes up, right? So down, and then up, down, and up, like that. So that's the annoying part lah. Yeah. So what's the amplitude of the oscillation? 2 not 4 because you need to take from equilibrium, right? Yeah, equilibrium is 4. Okay so far? Yeah. I mean it's SHM, yeah, so I can go through SHM, but yeah, later on. It's just about this graph, right? So you got to have to do 2 and 6. 2 and 6 here like this. Okay? Yeah, your graphs are a bit sharp though. So I mean, based on all the calculations, you will calculate the total energy. Right? You will calculate the total energy. I don't know what's the total energy. Like, how do you calculate the total energy? From the previous parts, right? Yeah, then you got total energy. What? 7.02 times 10 to the power minus 3 joules. Right? So you have to find that graph here. So you have to find it at the 7. Oh, but you indicated the correct value though. Why do you get... Oh, you just anyhow randomly choose a box. You didn't go by scale. You just went to choose a box. You went 1, 2, 3, 4 box. Is it something like that? Yeah. No, you're supposed to draw a proper scale. You got to have a proper scale. So your scale must be 2, 4, 6, 8. Then the 7 will be somewhere here. In between the 6 and the 8 lah. You cannot just choose one random box and call it 7. You know what I mean? That's what you did. Yeah, that's what she did. Right? You look at the original answer. Wait, you look at the original answer. She just put this point here at 7.02 and then she draw like that. So you just say, okay, that will be 7. And then random one, no scale one, you want. Right? What? Oh, do you put 2SF and got marked down? No? Oh. No lah. I mean, okay, I'll look at it. Oh, where did okay, what's this 2.2 times 10 to the power minus 2? Where's that? That's 2 cm. Okay, but 2 cm is 2 cm. What's this? Period, right? No, frequency. This frequency. Oh, that's period. Sorry, that's period. 0.6 seconds. Well, how did they give it? In the graph. In the graph was given as 0.6 seconds. Okay, so that's 1 SF though. This one 1 SF. 0.320. Oh, but they gave it at 320 grams. This can be considered as 2SF or 3SF. It could be considered as 2SF or 3SF. But doesn't matter, right? So technically speaking, you left your final answer here as 3SF. So if you leave your answer as 7.0, you shouldn't be marked down. Yeah, it should be okay. Yeah. What's the concern here? Oh, yeah. Oh, yeah, that's fine. Yeah, that's fine. Yeah. So you see, right? No, I think what's the important thing is this, guys. She didn't get marked down. Yeah, because not that big an issue. Most of the answers, 99% of all the answers that you do for A levels, paper 1 all the way to paper 3, not practical included, right? Usually 2 or 3 SF, you'll get away with it. But never ever leave it as 1. Don't write 7 times 10 to the power minus 3. You definitely will lose a mark here. Like if you write 7 times 10 to the power minus 3, it is not 1 mark minus from the entire paper, no. It's 1 mark minus here. Because that's a blatant abuse of the significant figures. You know what I mean? So it's either 2 or 3. 2 or 3. Or like never 1, never 4. It's either 2 or 3. So you decide. So sometimes if it's 2 or 3, even if you leave your answer in 3, you still get a mark. It's okay one. Because it's not blatantly wrong. 7 will be blatantly wrong. Sorry, what? Which one? The graph? Why did they... Sorry, what's your question again? Why did they add a negative 1.41? In which part, sorry? Oh, I don't know, man. Oh, no, it's for this one here, is it? It's for the part 2, right? For the part 2, determine at which the PE and the KE are equal to each other. Hang on. I got a weird one for you. Your answer key, right? Why is the top of the KE touching the total energy point? Like literally, is it? Like the maximum value of your answer key is what? The kinetic energy maximum value is? Is it that? That doesn't sound too right though. Exactly. You're right. No, but the total energy of a system is the sum of all the KE and the EP, right? So when it's passing through the equilibrium, when it's passing through the 4 cm, the EP shouldn't be completely zero though. Didn't wait, hang on. Total energy. Yeah, that's a bit weird though. But yeah, I guess you're right, Chloe. Right? If you let's say you take the a point as a reference for the EP, then I guess you can just assume that it drops to zero. But it's a bit weird lah. Did the teacher not mention that this question was a bit flawed? Oh dear. Okay. It sounds a bit. It sounds a bit weird. This one does sound a bit weird, but oh no, because there is still some no, Cassandra, if let's say you when you're passing through equilibrium, the upthrust and the weight balances each other out. So I guess in a way, if you take that as your reference point, then the GPE is zero. You can just take the GPE as zero there. Yeah. Then if you go up, there's GPE. If you go down, there is. Yeah, what's that? What kind of energy is it? I know there's more upthrust, right? But what kind of energy is it? What? Water potential energy? What's that? Yeah, they just call it potential energy, right? Yeah. But she's right, lah, I guess. But I mean, I'm also quite surprised. I mean, it's like that means based on what you're asking, Chloe, right? Why do we have to add the 1.4? Is this because of this one here, right? 4 cm is your equilibrium line. 5.4 is the point where the EK is equals to the EP. That's when the two graphs cross each other down here. That's when the two graphs intersect each other like this. Yeah. Okay? And therefore, you're supposed to mark out that point as what? 5 minus 1.4. Sorry, 4 minus 1.4 and 4 plus 1.4. Yeah, plus and minus. So it will be these 2 points here and here, right? But technically speaking, your graph, I mean, you did the corrections, yes, but technically speaking, your graph should look more like a quadratic curve rather than like a pointy spaceship like that, right? So it's a quadratic curve. So it's supposed to be more like a curve. Okay? Right. So I mean, that's not a big issue. To be able to draw the graph in the first place already is one big thing already. But yeah, so there you go. So you have to use the equation to equate KE and PE, right? Yeah. But it's not half. It's not 1/4 of your. It's not half your displacement. It's not half your amplitude. Yeah. So that's one common mistake a lot of students make is that EK/EP, right, somewhere in the middle here, they think that that's 4 divided by 2. That's not it. Yeah. Or 2 divided by 2, like 1 cm, they think. That's wrong. In fact, it's root 2 lah. Right? It's root 2. It's root 2. So this is the how the graph is drawn. Yeah, okay lah. I guess I'm just a bit surprised. Same. Doesn't matter. You see a spring mass system? Spring mass system, right? Okay. Hang on, Right. So how do you oscillate this thing? They say they lifted it up, is it? They push it down. Then you oscillate like this. Okay? Versus you lift it up by the same amount and you let it oscillate. Same. You push it down by 5 cm, the amplitude is 5. You push it up from equilibrium by 5 cm, the amplitude is still 5. So the KE and PE will be exactly the same point. Doesn't matter. You know when you see this graph like this, right? When the object is oscillating up and down, right? So the object go up, then as it goes down, and it goes up, and it goes down. So the object, right, as it's oscillating, is just going back and forth on the graph. Yeah. The KE the PE is going back and forth. The KE is going back and forth like this on the graph. So where they intersect, where they have the same KE and PE is the same point. Wow. Oh. Oh no, you know why? Because they're being very specific with the question. So the distance at which the PE and the KE of the KE and P equals to the KE, EP equals to KE, right? Just after being displaced downwards. So that means they're looking for the distance just above the lowest point. Yeah, which is where? On this graph, where? Here. This one here, 5.4. The key phrase is just after. Look at the question. The key phrase is just after, right? Just after being displaced vertically downwards. What if I ask you, just after being displaced vertically upwards? Yeah. Yeah. So you see, right? I thought you were asking me where are the points where the KE and EP are equal. The points are the same. Whether or not you displace downwards or displace upwards, it wouldn't change. But because now you're talking about this specific question here, you're asking me why did they add and not minus, right? Then my answer to you is because they're asking specifically for just after. What's your equilibrium position? 4. Where do you push it down to? 6, right? So when you let go of the object, like, you know, where does it go first? It goes upwards. And the point whereby the K and EP is equal is somewhere here, which is the 5.4 mark. If they ask you, like, when's the second time? If they ask you, I change the question again. When's the second time the EP equals to the EK? Then that one will be above the 4 cm mark. The second time, or first time is here, second time is there lah. Yeah, that's what. Yeah, I mean that's what. Yeah, can, no problem. Okay, what's the next one, man? 7. What's up? 6. 6. I what? IV. Oh, that's disgusting, man. What's this? Calculate the wavelength of the microwave given that the first minimum the ammeter reading is obtained is x equals to 0.2. Is this a scenario? For IV, this is a scenario? It should be, right? 6.3, right? I mean, they've gone so far down already, it should be 6.3 lah, right? Okay. And you're supposed to find what? The first minimum ammeter reading when X is 0.2. How about Y? Do we know what Y is? Is that it? 90 cm? Okay, 90 cm. And then X is 0.2 cm or meters? Okay, I mean 0.9 meters, 0.2 meters. Is that right? Okay, good. Why would that be a minimum even? Why would that be a minimum? Are you getting interference? Yeah, I only have one transmitter, right? Do you see any interference going on? The answer is yes. So you're suggesting to me that the wave is traveling from the transmitter, hits the reflector, and then goes to the receiver R. This is one source. This is the first source. And then there is another source which travels directly to the receiver. So this is source 1 and this is source 2. All right, do the math. What is the distance traveled by source 1? Yeah, to do Pythagoras theorem. Right, so 0.45, 0.2, right, and then you need to times that. So 2 times square root of 0.45 squared plus 0.2 squared. Yeah, quick math. What's that? 0.985. Some more? 0.985? I'm going to go with 0.9848. 9849. 9849. Okay, meters. All right. How about the second part? Second part is 0.9 only, right? So what's the path difference? Yeah, 0.0849 meters. You okay with this? Okay. Now this question is a nightmare. These people who set this question are nasty. All right. So what are we supposed to get at the receiver? What's the objective to get the receiver? Yeah, I want a minimum. Right? I want minimum, which means what? Which means what's the path difference or phase difference to get a minimum? Basically half a lambda, right? The smallest one will be half a wavelength, right? Okay. Unfortunately. So something else happens. I don't know whether this is included inside whether your school did this, right? But by right, you're supposed to have this, yeah. When there's a reflection, there's actually a phase change. Did they do that? No, they didn't. No. These people are nasty, man. What? The answer key says that there's no phase change there at the reflection. Wait. Does the answer key include that part about there being a phase change? No phase change. Bloody hell. Huh? No phase change. Then that means straight away this 0.0849 is half lambda, lor. Oh, these people are nasty, man. Okay, you know what you can do? You can go and ask your teacher, is there a phase change here? No. Tell me more about that. How do you know that there was? Exactly. There should be a phase change of pi radians, which means that it's out of phase, right? So in order to get a minima here, right? Like this thing should represent one full wavelength. That should be the answer. 0.0849 should be one full wavelength. And the teacher says, ah, there you go. Remember, I taught you this, right? I was teaching you this. Yeah, hitting the surface supposed to have phase change, right? So the question is there phase change or not? Okay. So for A levels, A level standard, right? If you ask me what's the um standard for A levels, there must be a phase change. Okay? But do we know the exact answer key? We never know, right? So I suspect A levels is divided on this. So I believe that A levels will accept either answer. Whether you take this as one wavelength or you take this as half a wavelength, at the actual A level exams, if this question comes out, right, they're actually okay with both. Yeah, which is fairly annoying because there's no standardized thing to that, right? So my suggestion to you guys is, no, go and check with your teacher. Follow school. The school says what? The school, one says no, got phase change, and the other one says no phase change. Go and check whether there's phase change. Because if there's a phase change, then this is equals to lambda. If there's no phase change, then this is equals to half lambda. Because that's the key thing, right? Wouldn't you want to get it right? Okay, I can tell you this, right? All the other schools, they go with phase change on. So your school is not clear on this. So get some clarity. Yeah. Okay, if you're a teacher, why would I test you? There's something that's come out in my tutorial before. All right, bro. Understand, right? That's why I will pull out all the other schools' prelim papers. Yeah, because like to expose you to other questions. Okay? Right, so that's a bit unfortunate. Well, that's damn annoying. Yeah. But anyway, you didn't get it right. you go and Pythagoras at 0.9. Hey, your triangle. Ma'am, you go and use Pythagoras on the isosceles triangle. Use it on the right angle triangle. Alright. Okay, next one, 7, is it? Oh, your container ship, what's this? Water resistance, ah. And then? Okay, this is your data response question. This is what we call the DRQ. Alright. Part what, ah? Huh? Isn't that the drag force is proportional to the velocity squared? Oh no, not squared. The drag force is proportional to the velocity. So as the ship slows down, the drag force changes, right? And since the resultant force is the engine force minus with the drag force, so the resultant force keeps changing, ah. That's all. That's all, bro. Wait, what? Oi. Wait, what? Oh, Cassandra, that's you using the data to show that the velocity is not constant, and therefore like you're explaining using data. That's not what they want. What do they want? Okay. To be honest, they're asking you to explain using forces, using your understanding about the resistive force, the drag force. They're not asking you to read to show from the data that the resultant force is not constant. Yeah. So that's a bit unfortunate. Okay? That's the reason why you lost marks there. What else? Part CI. What? Okay. Get the equation for the work done on. Okay. What's the question again? What are the fenders? Yeah. What are they? Are they springs? Are they considered as springs? Sorry, where does it say? Oh, where? No. Oh. Oh gosh, sorry. Yeah, so springs, right? So what's the EPE? Yeah. Okay, guys, listen. It's half kx squared, but the equation is half fx. EPE is half f times x is equals to half kx squared. Did you calculate k? You didn't give k, right? Could you calculate k? You could calculate k, but if you calculated k, then it's half kx squared. Oh, you did? So energy, elastic PE is half fx. Why? Why? From the graph of f versus x, right? You will get a straight line like that, right? So work done on the spring is area under the graph, half f times x. Yes, f equals kx. Sure. Okay. Which is fine if you calculated it correctly. You put 2 times half kx squared. Oh, hang on, sorry. Hello? Yeah, I know. I need to wrap up. Yeah. Yeah, okay. Okay, bye. Guys, I gotta go soon, Hang on. Yeah. What? Sorry, what's your question? Sorry. Which thing? Sorry. Because it's half fx. Is the area under the graph. Half fx. fx. Half fx. I know the equation is half kx squared, but that's because you subbed out f as kx. Then it becomes half kx squared. But the original equation for EP of a spring system is half fx. Can. You should get it right too. But I heard you say something. Why is it not multiplied by 2, is it? Because you're supposed to see 2 fenders, is it, or what? That one I don't know, man. I mean, I see 2 fenders as well. Right? I see 2 fenders as well. I'm not too sure why you're not calculating it as 2 times. Yeah. So they just assume that the fender is one entire system. It's got nothing to do with physics, man. It's something to do with your teacher. It's just fender system, lor. Right? They're just treating it as one spring, lor. Like you treat it as one spring, yeah. Then there will be a problem. Yeah, it's frustrating. Yeah, that one's but you need to get past this one here. Chloe, this one is important. You need to understand why is the EP that, because it's the area under the graph. Yeah. Okay. Yeah? What's up? Yes? No, like I said again, if there was a phase change, this will make it out of phase, right? Which then nicely gives us the reason why it's minimum, right? So the smallest value, if there's a phase change, right, then 0.0848 is 1 lambda. But if there's no phase change, right? If there's no phase change, that means it doesn't change it to pi radians. So in order to get it to be a minimum, then their difference must be half a wavelength. No. They are telling you that I want a minimum here. So what's the wavelength in order to get a minimum here? If there's no phase change, how do you get a minimum here? Huh? No, how do you get a minimum here? The first wave must be longer than the other wave by how much? Half a wavelength. Then that distance will be half a wavelength. Yeah. Yeah, this is if there's no phase change. Which is why I asked you if there's no phase change, right? You know, whether or not it's phase change. Because if there's a phase change, then it'll be another value. If it's, you know, if there's a phase change, then this 0.048849 is 1 wavelength. If there's no phase change, then it's half a wavelength. Plus what? No, question is, do you want phase change or not? So there's phase change, huh? There's phase change. If there's phase change here, how do you get a minimum? Plus 1, where does this plus 1 come from? Plus 1 what? Plus 1 meter, plus 1 wavelength? No. You don't have to think about the n plus half lambda. You're thinking of it in equation. Don't think of it in equation. Think about this. If there's a phase change here, that means you flip the amplitude. From positive, you flip it to negative, okay? Right? You flip it, huh? But you still want a minimum here. You have to flip it again, right? So then the path difference will be. So what happens is that if there's a flip here, right? It already will help you to get a minimum. It will definitely give you a minimum already. Then the path difference will be what? It will be 1 wavelength. You don't have to go and plus anything. It will be 1 wavelength. So if there's a phase change, okay, then the total path difference will represent 1 wavelength. Because the objective is I want a minimum here. A minimum is when I'm pi radians out of phase. Right? So there's no plus 1. No, it's already flipped. If there's phase change, that's why I ask you the first thing is this, do you want phase change? You want phase change, so is it flipped? Huh? It's flipped, right? Then if you flip again, it will become a maximum. I don't want that. What does the question want? The question wants what? What do the question want? The question wants a minimum. So you already flip once already. Do you have to go and flip it again? No. Do you need to flip it again? Should you flip it again? What happens if you flip it again? Yeah, so do you want a minimum? Does it get flipped here? Right, so the path difference must be what? In order to keep it like that. 1 wavelength. So that you can get a minimum. Because you need to remember that's the objective of the question. The question wants you to get a minimum there. Yeah. I got to run. Like literally I have to go run off now. So Yu Heng, I will, if there's anything else